we do use substitution because we can't integrate some things just in our head. It's a method. If you look on this day 3, you see this little phrase, TOCO. Okay, that is something another teacher came up with just to kind of distinguish that, okay, we've been doing use substitution, we're going to continue it, but there's some problems that are a little bit different. It's not a completely brand new thing, okay, but what TOCO stands for is that other kind of substitution. Okay, I want to first explain to you why we need something else, like why use substitution doesn't work, like regular use substitution doesn't work on every problem, why we need to modify it. So if we look at this problem right here, the first thing we would probably want to do, and let's just ignore the words for a moment, what it says, try not to look ahead yet, but probably what you would want to do is rewrite it like that. Okay, and once you rewrite it like this, it makes figuring out what u equals a little bit easier because now we have parentheses and a power. So what should u equal? 2x plus 1. Okay, so we're comfortable with that. Let's keep going with what we're comfortable with. What would du equal? 2 and dx. So I want you to notice something. The thing in parentheses right here is going to get replaced. Excuse me, with a u. The dx, what is it going to get replaced with? A 1/2 du, right? But then we have something extra. We have not seen this yet. Before now, if there was an x here, it was because it was part of the x dx. Okay? So we have to do something extra. It's not that bad, though. What we have to do is we have to say, okay, well, what would x equal? If u is equal to 2x plus 1, what would just x equal? Yeah, you subtract 1, so it's like you have u minus 1. That's equal to 2x. Divide by 2. If you're still struggling with regular use substitution, this is going to seem like straight up alien stuff. Okay? So just hang with me here. But this is why we have to have something else. Okay, I'm not going to finish this whole problem. Actually I am. Never mind. I didn't in my other classes, but we have some time here. So look at what happens. You replace the x with what it equals. Okay? Along with the rest of you use substitution. That's what happens. Now, if you're like, I don't know how we got there, just pin that. And for right now, what I want to do is finish this problem. You have to simplify before you integrate on these. On these TOCO problems, you have to simplify. Watch what I'm going to do here. Let's put the 1/2 here. This square root of u. Well, hold on. Sorry. I'm going to first rewrite that as 1/2 u minus 1/2. You have options here. What I'm showing you is what I think is the easiest way to explain this. Okay, I don't want the fraction. I also don't want the square root, so I'm going to make that into u to the 1/2. So this part, we're going to work as we go along. This won't be too bad next time we do a problem. Now, what we have to do is distribute before we integrate. Because I don't have product rule for integration. Okay, so then I have the 1/2. And watch what happens here. When you multiply 1/2 u times u to the 1/2, you are going to get 1/2 u, and the power on u will be if you add those two powers, just because that's the rules of exponents. So this would become 3/2. Not because I'm integrating, but just because I'm multiplying 1/2 u times u to the 1/2. The next one's a little bit easier. Negative 1/2 times u to the 1/2 would just be like this. And it looks like I'm making this messier, but at least now this is something that I can integrate. Once you get ready to integrate, put a bracket or a parenthesis instead of an integration symbol. Okay. Can you integrate 1/2 u to the 3/2? Yeah, don't worry about how messy it is. Let's just think of this. 1/2 over something. U. What would be the new power on u? 5/2, and that's what goes down here. Don't worry about how messy it is yet. Okay, minus 1/2 over something. This would be 3/2, and then we're going to put 3/2 down here. And then I'm going to put the tiniest little plus c there. It's super messy. Do we have to simplify? Heck no, we're not going to do it. All right. You would if it was multiple choice, and we're going to talk more about that thing tomorrow. Today, we are not going to worry about simplifying whatsoever, though. The only other thing you would have to do, and I don't want to rewrite this because I kind of ran out of room, is you would need to plug what back in for u? 2x plus 1. Okay, so this is a problem for the most part. I just walked you through it. We didn't really do this problem. So you have some questions. Let me go through an example start to finish. And then ask your questions as we go along in this next example, okay? All right, so this example 1, I'm gonna make this bigger so I can write bigger. All right, so first of all, what's the first thing? You may be like, I don't know how to go from start to finish, but you know what to do with square root symbols. And what is that? Make that into parentheses 1/2. And if you want to rewrite it, you can. If you want to just put it on there like that, you can. I have 2 things in parentheses. So which one am I going to let u equal? Pick the messier one. Pick the one with the power. Pick the grosser one. So u is going to equal 2 minus x. All right, so then what would du equal? -1 dx. They started a garage band next door, apparently. All right, so if you look at this, that dx, I have that dx right there. Okay, I need to move over the -1. I can do that. But I have something extra, and that is x plus 1. So we have to account for that. It'd be nice if there was an x plus 1 next to the dx, but there's not. So we have to just deal with it. So if u equals 2 minus x, what does just x equal? Two minus u. Let's let this sink in first. I didn't show all the steps here, but it's just add the x over, subtract the u over. Okay, and if this had just been a single x, I would put in a 2 minus u. But it's x plus 1. So what does x plus 1 equal? 3 minus u. Just add 1. I don't know. So look at what's going to happen here. The negative here, this -1, we know that's going to go out to the front. That's still going to, we can rely on that. In place of x plus 1, we are going to write 3 minus u, because see, they're equal here. So I can swap one out for the other. In place of 2 minus x, I'm going to write a u, and that's to the 1/2. And in place of dx, I'm going to write du. Now, I've color-coded this to try to help you guys follow along, like how I did it. The yellow is the extra stuff that we haven't seen before today. That's what makes this a TOCO problem. Stands for that other kind of. By the way, through Friday's test, I will tell you if there's a TOCO problem. You will not have to, even on the test, this test, figure out if it is a TOCO problem. That's actually, you may not realize, that's a really nice thing. I'm not trying to brag on myself, but I'm just saying it's going to really be helpful, okay? And that's just because this is something new. We have a test coming up pretty quick, so I want you to be able to do this, but maybe not know when to do it yet. That's okay. That'll come in the week. We're going to continue integration for several weeks. So, all right, so let's continue. Before you integrate, you've got to distribute. So 3 times u to the 1/2, that's 3u to the 1/2. What would be the next distribution? Yeah, 3/2. Because this is like u to the 1 times u to the 1/2. So I'm still writing the integration in the du because I haven't actually anti-derived or integrated yet. I've just rewritten it. Once you're ready to integrate, don't write the integration symbol anymore. Write a bracket or parenthesis or something other than the integration symbol. And now we need to anti-derive. So the coefficient is 3. It's still 3, but over something. The new power on u, I'm going to add 1. And then write that down here. Okay, 1 over something. Write your u, add 1, that makes that 5/2, and 5/2 is what comes to right down here. I'm going to close that bracket and put the plus c. We're almost done. The next step really is supposed to be the easiest step, so don't get stressed out at this point. Okay, you don't have to simplify, but your excuse me, your final answer, you need to go back to where we started. U was supposed to equal 2 minus x, so let's do that. If you feel comfortable today simplifying this and you want to, that's fine. Does anybody know what 3 divided by 3/2 is? 2. Good. You don't have to do that though. And if you're not absolutely certain, don't do it. So put the 2 minus x back in place for u. This is going to become 2/5. You can write that if you want. I'm going to not simplify on the screen. Okay, is this gross? Yes, but it's correct. So it's not a completely new thing, but it does add in some new steps. Okay, I'm going to skip example 2, and I want to do example 3, and that'll probably be it for today's lesson. Okay, so first up, I need to rewrite this. Anybody have an idea of how I can get rid of the square root and the fraction in one turn? Yeah, the 1/2 for the square root, and the negative is because it was in the denominator, but not anymore. And when you write it this way, naturally, you should naturally go, okay, I'm pretty sure I know what u is supposed to be. The thing in parentheses. And then du, just take the derivative. That's going to be 2 dx. Looking at the problem, I see a dx that lines up. The 2, though, I need to divide that over, and that's the same as with all the U substitution. That's going to happen on most of the problems. And that's going to put a 1/2 out in front of your integration symbol. So what makes this TOCO is we have this extra x. It'd be great if this x was not there. Or if it was also over here. So it's not. We got to put something in place of that x. Go over here and figure out what x should equal. So go ahead and do that on your own. If u equals 2x plus 1, what is just x? And I'm going to write this 2 different ways. Which way do you think is going to be more beneficial? The second one? The first? Honestly, you can make it work either way. I'm going to pick this one. I want to show you why. Because I know that I need to multiply and distribute, and it's going to be much easier to distribute this than that. There are ways around this. And I'm only even mentioning that because some of you are very clever and you come up with ways to simplify all on your own. No matter what you write here, you've got to simplify this before you integrate, though. To me, that's the annoying part of these problems, is that algebra step. But if you do practice it, you're going to get better at it and better at it. So 1/2, what would be the power on u? 1/2. And then this one's a little bit easier. Notice I'm still writing the integration symbol in the du because I haven't integrated yet. I've just been simplifying. Once you're ready to integrate, you need to not write the integration symbol and write the bracket. Go ahead and see if you can finish this one on your own. There's 2 more steps involved. I'm going to write it up here. Feel free to kind of check what you're doing. If the simplification is overwhelming you, don't simplify. Don't forget that plus C either, by the way. So very gross final answer.